What is the maximum permissible voltage distortion according to IEEE standard, and briefly explain low frequency harmonics in distributed generation. So here distributed generation that does not produce a complete sinusoidal current waveform. It will not produce complete sinusoidal waveform. Okay, just like the majority of the other equipment. So majority of the equipment will produce a sinusoidal, but what about the distributed generation? It will not produce a completely sinusoidal current waveform. So the harmonics injected into the distribution grid, the harmonics injected into the distribution grid by the generator will result in some increase in the voltage distortion. So what happens? Distributed generation, what we connect in, that is distributed generation. Here the harmonics are injected. Okay, harmonics are injected by the generators. Okay, harmonics injected into the distribution grid by the generator, that will result, what happens, that leads to the increase in the voltage distortion, increase in the voltage distortion. Emission by distributed generation. So distributed generation emission is less when you compare with the modern consuming equipment. So emission by distributed generation is smaller than the emission by modern consuming equipment. So here presence of distributed generation, that will increase in the level of frequency components, that is frequency harmonics. Because of distributed generation, that increases the frequency harmonics. Okay, here in traditional power system, what happens, it is the frequency components like higher order triplet harmonics and interharmonics are small. Okay, it will be having a small. These frequencies have traditionally been used for power line communication in traditional power system. So these frequencies, what triplet harmonics and interharmonics have been used for power line communication in traditional power system, based on the fact that disturbance levels were low here, because in traditional power system the disturbance level is low. Okay, so these frequencies can be used for the power line communications. So here increasing amount of distributed generation. So we have connected only the, for example, distributed generation, two sources we are using. So if we added one more source to the grid, okay, distributed generation, so increasing the amount of distributed generation could therefore result in interference with the power line communication. So that will lead to the interference with the power line communication. So before, what it was, because of distributed generation there was a harmonics. Okay, the level of frequency, increase in the level of frequency components, that means it is increasing the frequency harmonics. Okay, because of distributed generation. So if you increase still more distributed generation, that will lead to the interference with the power line communication. So the harmonic emission of distributed generation is low for the frequencies that have traditionally been of concern for harmonics 357 up to 1 kHz. So here the emission of distributed generation is low for what? Low for the 357 up to 1 kHz frequencies. Okay, for these frequencies it is emission is low, That is what they are saying. So the harmonic emission of distributed generation is low for the frequencies that have traditionally been of concern for harmonics, that is 357 up to 1 kilohertz. Here, a maximum permissible voltage distortion of 3% is assumed in accordance with IEEE standard 519. So the three typical medium voltage feeder of different length are considered. The limits are reached for triplen harmonics. The high harmonic voltage levels are expected first for triplen harmonics at long feeders. So high harmonic voltage levels are expected first for triplen harmonics at long feeders when the generation is concentrated toward the end of the feeder. So high harmonic voltage levels, okay, this is high harmonic voltage levels are expected for the first triplen harmonics, okay, for first triplen harmonics at long feeders when the generation is concentrated toward the end of the feeder. It was simply assumed that the emission is exactly equal to the limit set by IEEE standard 519 for large customers, and without further information about the actual emission, it is difficult to know if these limits are conservative or non-conservative. Without information actual emission, it is difficult, right? So it is difficult to limit whether it is limit the conservative or non-conservative. However, if the network operator, for example, if the network operator forces to follow the IEEE standard, okay, forces to follow the IEEE standard 519 limit on the generation who are generating, for example, different types of generation is there, and if the network operator is forced to follow this IEEE standard 519 limit for them, then the harmonics will be, voltage harmonics will be less, okay. If the network operator imposes the IEEE standard 519 limits on the generators, there will rarely be high level of voltage harmonics due to distributed generation.